Welcome back to All This Math. This is Professor Parker. Make sure you like this video. Make sure you share this video with somebody. And if you're not already subscribed, make sure you subscribe to the channel. All right. Now, what are we doing today? We are factoring out a GCF of an algebraic expression in order to factor it into simpler terms. Now, first thing, don't get intimidated. All right. There's a lot going on here. We got a lot of different variables, a bunch of different exponents. We got negative signs. Relax. Take a deep breath. Don't get intimidated. All right. Now, what I tell students is this: identify your coefficients. If you're looking for a GCF, a greatest common factor, look for your coefficients. First, identify your coefficients and then take the GCF of the coefficients first. All right. So I got a -4 as my coefficient of this term. And then I got a -2 as my coefficient of this term. Now, I'm going to treat these like they're +4 and +2, right? That's what I'm going to do. What's the GCF of 4 and 2? What's the greatest common factor of 4 and 2? It's not 4. That would be the lowest common multiple, or the LCM. The GCF of 4 and 2 is 2. Why is that? Because 2 is the greatest number, or the biggest number, that can multiply into both of these numbers. Watch. What's 2 times 2? 4. What's 2 times 1? 2. 4 can't be the GCF because you can't multiply 4 by another whole number or integer and get 2. You can do 4 times 1 and get 4, but you can't do 4 times no whole number to get 2. That's why 4 is not a GCF. A lot of students, or maybe you watching this video, you might be a person that might make that mistake because you don't fully understand the difference between a greatest common factor and a least common multiple. Do yourself a favor. Look at my playlist on factors and multiples so you can fully understand once and for all the difference between greatest common factors and least common multiples, so you won't be making that mistake, right? Don't confuse GCFs and LCMs. Don't do that to yourself. All right, so look, what I also tell people to do is, with problems like this, just write the GCF somewhere, right? So you got GCF, take the GCF for the coefficients, which is 2. And you might be wondering, well, how come it's not -2? We could use -2. I don't want to use -2. I'm going to just use 2. So we got 2. And then we look at the variables. So then we start looking at the variables. So I see I got a P in this term and I got a P in that term, right? How do I know which one is the GCF? The way you know which one is the GCF is you take the variable with the smaller exponent. You take the variable with the smaller exponent. That's what you do. You take the variable with the smaller exponent. So 2 is less than 3, right? So that means we're going to take this, p squared. So now we got p squared right here. And then we do the same thing with the q's. Q to the 4th power, q to the 5th power, right? Q's, right? Like Carter G. Woodson was a Q, a member of Omega Psi Phi, right? So we got q to the 4th and q to the 5th. 4 is less than 5. Also, Carter G. Woodson, founder of the Association for the Study of Negro Life and History, which today is the Association for the Study of African American Life and History. Also the founder of Negro History Week, right? Which eventually grew into Black History Month that we recognize in February. I talked about that on other videos in the past. Go check those out. All right. So q to the 4th, because 4 is less than 5. So this is my GCF. Now, next question is, what do I do with the GCF? What you do with the GCF is you write it down adjacent to a set of parentheses. So you write 2 p squared q to the 4th. Make sure you know where this 2 came from. Make sure you know where this p squared came from. Make sure you know where q to the 4th came from. Rewind the video, hit pause, run it back if you don't understand where this 2, this p squared, and this q to the 4th came from. You need to understand the steps and the rules because you do every single problem the same way, no matter what it looked like. Next to this, you write parentheses. Now, next question should be for you that you should have is what's going to go inside the parentheses? Why we got just a set of parentheses with nothing inside of them? What's going to go in there is the quotient when you divide each of these original terms by the GCF. Now, how many terms are going to go inside there? The same amount of terms we started out with. If the original expression had 2 terms, you're going to have 2 terms in the parentheses. That's how it works every time. If we had a problem with 5 terms inside the 5 terms in the original expression, that means we're going to have 5 terms inside the parentheses. That's just what it's going to be. All right, so now we're going to do some division. We take the first term, negative 4p to the third, q to the fourth, divided by 2p squared q to the fourth. Now, we're going to divide the coefficients first. Negative 4 divided by positive 2 is going to be negative 2. P to the third divided by p to the second. Now, you need to know the exponent properties. You need to know the exponent properties. I got a whole playlist on exponent rules and exponent properties. Go check that out. That's why you should be subscribed. All right. The exponent property for division says that when you're dividing the same term or the same variable, you will subtract the exponents. 3 minus 2. Top, down, not bottom up, top, down. 3 minus 2. 3 minus 2 is 1. So this is going to be p to the first power. We don't really need that 1, but I'm going to just write it there for right now. All right, then we go to the q's, right? Again, q's, Carter G. Woodson, a member of Omega Psi Phi, right? Q to the fourth divided by q to the fourth. So that's the same term. Anytime you divide a term by the same term, whether it's a variable or a number, the quotient is 1. It's 1, right? So you got negative 2p to the first times 1. So this one you don't need, and this one you don't need, because negative 2p times 1 is just negative 2p. And you never need to write the exponent 1. When 1 is your exponent, you don't need to write it. Write that down and memorize that rule. When the exponent is a 1, you don't need to write it. All right? So what I'm going to do with this negative 2p, I'm going to throw it inside the parentheses. Right there in the first spot, because it came from the term that was originally in the first spot. So this goes in the first spot. Then we're going to do the same division. We're going to divide the second term by the GCF. So we're going to do negative 2p squared q to the fifth divided by the GCF. Same thing. 2p squared q to the fourth. What's negative 2 divided by 2? Negative 1. What's p squared divided by p squared? Whenever you divide something by itself or the same thing, the quotient is always 1. So we got times 1. Then q to the fifth divided by q to the fourth, you subtract the exponents. 5 minus 4. In this situation, 5 minus 4. 5 minus 4 is 1. 5 minus 4 is 1. So we're going to have q to the first. Q to the first. So we got q to the first. Right? Now, let's clean this up. Negative 1 times 1 is negative 1. Negative 1 times q to the first is just negative q to the first. It's negative 1 q to the first. But if your coefficient is a negative 1, listen to this. If your coefficient is a negative 1, you don't need to write the 1. All you need is the negative sign. If your coefficient is a negative 1, you do not need to write the 1. You just need to write the negative sign. So this is equivalent to just negative q. Now, what happened to this exponent? Oh, what did I already tell you? When your exponent is a 1, you don't need to write it. When there's no exponent written, you're supposed to just know. This is part of algebraic language or math language. You're supposed to just know that the exponent is a 1. And if you don't see no exponent, that don't mean the exponent is a 0. If it's a 0, you need to write it. If it's a 0, you need to write it. And then in terms of simplifying, you would apply the 0 exponent property, which means the whole term turns into a positive 1. Right? The whole term, not just the exponent, the whole term turns into a positive 1. But if you have a variable or a number with no exponent written, that means that it's understood that the exponent is a positive 1. So this is minus q. All right, so we throw that in there. Boom. This is our final answer. This is our final answer. All right, 2p squared q to the fourth times the quantity of negative 2p minus q. All right, that's our final answer. All right, so go get some practice with these. Make sure you like this video. Make sure you share this video with somebody. Make sure you subscribe to the channel if you're not already subscribed. Oh, and also, this brother on my shirt, Black Panther Party member from out of Chicago, Fred Hampton. Make sure you get familiar. Do your research. Read some books about this brother. All right, read some books about him. Understand the work that he was doing in Chicago for our people. All right, that's your homework too. Practice these. Study Fred Hampton. All right, see you on the next video. Peace.